All right, good morning. Yesterday you learned how to take a number written in scientific notation and transfer it or change it into standard form. Today we are going to reverse that. So you're going to see a number written in standard form, and we are going to switch it to scientific notation. You will use this a lot in your science classes here in the next few years, and it's a good skill to remember. So grab your journals, write down this key idea. I'm going to read through it for you and pause me if you need more time to write it. So, when you go to write numbers in scientific notation, the first step is you move the decimal point to the right of the first non-zero digit, the first one being on the furthest left-hand side. When you move it, you count the number of places you have moved the decimal point, and that tells you what the exponent is going to be of the power of 10. So they give you two examples here. I'm going to go ahead and rewrite them so they're easier to see. If you start with number 8600, okay, we have an imaginary decimal here at the end of this. So you're going to move it to the first, so there's only one number to the left of the decimal. So I'm going to go 1, 2, 3. So I moved it 3 times, which means I'm going to get 8.6, and you always write down whatever numbers are after it, and unless there's zeros. The zeros you get to leave off, but if there's any number, you have to write that one. 8.6 times 10, it's always times 10, and then how many times did we move it? We moved it 3 times, so then this exponent becomes a 3. Okay, so now let's do it if you have a decimal. These are your really small numbers, 0024. So again, we're going to grab it where the decimal's at and move it so there's one number to the left of my decimal. So again, you can see I moved it 3 times. So I'm going to get 2.4, because if it has a number you have to write it, times 10. Now in this case, we moved the decimal to the right, so my exponent is actually going to be a negative exponent. If you move the decimal to the left, your exponent's positive. If you move it to the right, then your exponent is negative. And we moved it 3 times, so this one is a negative 3 exponent. Pretty simple. Make sure you write all of this in there. If you move it to the left, it's positive. If you move it to the right, it's a negative exponent. So the rules you need to remember. Okay, so let's go over example 1. All right, put this in your journals. Google purchased, this is example 1. Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. So you see the decimals at the very end. It's actually a period, but there's an imaginary decimal there. Which way are we going to move it? To the left. So you're going to go to the left and count it as you go. So there's 6 zeros. And you're going to go all the way to right after that 1, because you only want one number to the left of the decimal. So there's going to be 9 place values. Okay, so you're going to have 1.65, because you have to write anything that's a number other than 0, and then times 10 to the 9th exponent. 1.65 times 10 to the 9. And since we moved our decimal to the left, our exponent is positive. Good. All right, let's look at example 2. Okay, again, make sure you put this in your journals. You don't have to write the whole equation out, the whole sentence out. Just be writing down the number and how to change it. So, anyhow, the 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day 0.0000268 seconds shorter. So it barely messed it up. Write this number in scientific notation. So you can see where the decimal is, and we're going to move to the right, meaning our exponent's going to be negative. So grab that decimal and you're going to move it to the right until you're right after the number 2, because you only want one number to the left of the decimal. So you can count it and you see you move it 6 times. So that means you're going to have 2.68 times 10 to the negative 6, since we moved the decimal to the right. Good. 2.68 times 10 to the negative 6. All right, I think it's time to do some on your owns together. All right, here's number 1, 2, and 3. So, number 1, we have 50,000. So we're going to grab our imaginary decimal and move it to the left 1, 2, 3, 4 times. So you're going to have 5 times 10 to the 4th power. All right, let's look at number 2. We're going to move it 1, 2, 3, 4, 5, 6, 7 times. So 2.5 times 10 to the 7th power. And 683, 1, 2. So we get 6.83. You still have to write all 3 numbers there. Times 10 to the 2nd power. All right, let's do 3. Numbers 4, 5, and 6. All right, now we're moving to the right, so we're going to have negative exponents. So I'm going to grab my decimal, 1, 2, 3. So I'm going to get 5 times 10 to the negative 3. Remember, you move until one number is in front of the decimal. 1, 2, 3, 4, 5, 6, 7. So you get 3.3 times 10, negative 7. One more. 1, 2, 3, 4. And you see they tried to fool you by putting a 0 in there, but you're going to say 5.06 times 10. How many times did I move it? 1, 2, 3, 4 to the negative 4. So if you're writing it and you have a number that has a 0 between 2 numbers, you do have to write that number as well. It's just if you have zeros before or after that, you knock them out. All right, when you're doing your work, you don't have to do these little bumpy, squiggly things to help you count. I just do it so I don't lose my place, especially if there's a lot of zeros. You can just count them and do it. You don't have to show your work by doing that. All right, good. Let's look at the next example. All right, so now you're going to learn how to do some arithmetic when using exponents. All right, so we have an album has sold 8,780,000 copies. How many more copies does it need to sell to receive the award? You can see on the left there that we need 10 million copies in order to get an award. So we need to create a model or an equation. So we're going to have, we want to find out how many we need to sell still. We take what we need to, what's required, which is the 10 million, and we subtract our current sales. So we have 10 million minus 8,780,000. So if you subtract those, you're going to get 1,220,000. Now we change that into scientific notation. So I'm going to move the decimal to the left 1, 2, 3, 4, 5, 6 times. So moving to the left means it's a positive exponent. So I'm going to have 1.22 times 10 to the 6th. So then if you look up at our multiple choice, it tells you that that answer is C. All right, I think we have an example to go with this. Oh, no. Let's do example 4. So that was example 3. Let's do example 4. All right, now here's the next skill you need to learn. We're going to learn how to multiply scientific notation. So we're going to find the answer to 3 times 10 to the negative 5th times 5 times 10 to the negative 2. So the first thing you do is you're going to since this is everything in here is multiplication, you're going to separate out the coefficients of the original number, the 3 and the 5, from the two bases of 10. So I'm just rearranging essentially, and I'm going to move my 3 and my 5 on the left-hand side of my total equation, and then the 10s with their exponents on the right-hand side of the equation. And then I'm going to re-parenthesis these. So then, because I can do the left-hand side, 3 times 5 is going to give me 15. On the right-hand side, you guys remember when you're multiplying exponents, what do you do with the bases, with the exponents? What do you do with those exponents? You add them. Well, in this case, we have a negative 5 plus a negative 2, so that means it goes going to further negative, which gives you negative 7. So the first 3 times 5 gives me 15, and then that 10 to the negative 5th times 10 to the negative 2, add those exponents, negative 5 plus a negative 2 goes further negative to negative 7. Okay? Now the next thing we need to do is that 15 has too many numbers, right? We're only supposed to have one number to the left of the decimal. So if I grab my imaginary decimal and move it to the left between that 1 and 5, so I get 1.5, that means I'm going to have another 10 to the power of 1. Well, you notice this is a positive 1 because I moved the decimal to the left this time. So I get 1.5 times 10 to the 1, and I still have my 10 to the negative 7. Well, you just do the same thing. You're going to add these two exponents over here. The only difference is now 1 is positive and we have a negative 7, so you're actually technically going to subtract something from the 7 and get a negative 6. Because you're going from negative 7 back closer to 0 one time. So that's the negative 6. So your final answer here is 1.5 times 10 to the negative 6. Okay, so let's practice a few of these. Okay, now I'm going to show you a quick little shortcut that I do that's faster than rewriting everything like the example showed you. So instead of rewriting this whole equation in the new format twice, because they do it and put it in parentheses and they do it again, I would like to just draw on it. So I'm going to have my original equation 2.5 times 10 to the 8th times 2 times 10 to the 3rd. I know I'm going to put these two together, and I know I'm going to put these two together. So I'm going to have, and you go ahead and put in parentheses, 2.5 times 2 times 10 to the 8th times 10 to the 3rd. So now I've skipped the one step where we were kind of moving it around and we hadn't yet put in parentheses yet. I just do it by drawing. So now we can actually simplify this. So you're going to take 2.5 and multiply that times 2, which gives you 5, and then times 10 to the, and remember we're combining exponents, so the 8 and the 3 just subtracts. Nope, adds. Woo, almost did that wrong. 8, 9, 10, 11. So 5 times 10 to the 11th power. I only have one number over here in front of the decimal, so we're good. We don't have to simplify anything else. That's your final answer. All right, let's look at number 9. Again, I'm going to combine my primary number, first number, I don't know what to call that, and then my bases with the exponents. So I'm going to get 2 times 1 times 10 to the negative 4 times 10 to the negative 4. Okay, well, 2 times 1 is just 2 times 10 to the, and then you're going to add those exponents. So negative 4 goes further negative to negative 8. And again, you see I only have one number in front of the decimal on the left there, so I'm done. 2 times 10 to the negative 8. All right, let's do 2 more. All right, last 2. All right, so these ones, you can bet that we're going to have to simplify twice on here, but that's okay. All right, so for the first one, I have 5 times 5.4, and then times 10, and then I have to the negative 4 times 10 to the negative 9. So you're going to go 5 times 5.4, and you're going to get 27 times 10 to the, we have a negative 4 and a negative 9, so we combine those to get a negative 13. All right, and you guessed it, this 27 has too many numbers. Remember, you only have to have one number to the left of the decimal, so we're actually going to move our decimal one time. So that's going to give us 2.7 times 10 to the 1, because we moved it to the left one time, and then rewrite my 10 to the negative 13. So then to simplify this, we get 2.7 times 10, and we're going to add the 1 and the negative 13 to get a negative 12. And that's my final answer. All right, let's do the last one. We have 7 times 3 times 10 to the 2 times 10 to the 5th. So 7 times 3 is 21 times 10 to the 5 plus 2 would be 7. All right, again, we need to simplify further, so I'm going to move my decimal one time and get 2.1 times 10 to the, I moved it one time, so 10 to the 1, and then rewrite my 10 to the 7. So my last simplification, 2.1 times 10 to the, add the exponents, 1 plus 7 gives you 8. All right, shouldn't be too bad. I imagine you will motor through this. So you have already done on your own numbers 1 through 11. You need to do the practice and problem solving numbers 3 through 24. All right, good luck.